guys, welcome back to this page. We continue. Now, there's another question up here. Don't forget, this is brought to you by Wilder. Like, share, comment, subscribe. Alright, so I have a question up here. It said three consecutive numbers form geometric progression if the sum of the number is 28 and their total product is 512. 512, find the numbers. Let's solve this. Solution. Now take note, every information is important. Now I said they are consecutive numbers. However, there is now an extra information that they form a geometric progression. Now what do we mean by a geometric sequence? Now let's suppose I define a sequence of real number. Now when do we say this sequence? It is we have first term, second term, third term, like that. When do we say this sequence follows a geometric progression? It means that when I take the ratio of every term of present term with the immediate term, that is a2 to a1, a3 to a2, an to an minus 1, it will always be the same, and we call that value the ratio, the common ratio. That is, I can always express every term with respect to the immediate term as a multiples of the ratio, what we call the common ratio. So as such, in talking about consecutiveness, it's going to be defined in terms of the multiples of the radius of the multiples of each term. Now, so that means consecutiveness will give us, depending on the kind of progression you are dealing with. If it's an arithmetic progression, then we know that it's going to have a common difference. Now, if it's a geometric progression, then we're talking about a common ratio. So as such, I said that to say this, that means in defining those numbers, those terms, now let's the numbers, so now let's the numbers be, let's say I'm using a over r, a and a r. Now these follow a geometric progression. Now what do I mean? Let's check. Second term dividing first term, that's a dividing a over r, which is something I say a times r over a. You see, it gives r. What of the same thing also a r, the third term dividing a, that's still r. It's actually a progressive sequence. So as such, so the first information says the sum is 28. So this we have a over r plus a r equal 28. We call this equation 1. I said the product, so it is a r times a r is 512. This take care of this. So I'm left with a cube equal to 512. And which gave me the cube root of 512. What's the cube root of 512? We have 8 times 6 times 4 times 8. That's 8 times 6 times 6 48, that's 480 times 132. That's 512 exactly, because that's 8. So that means we have my 8 equal to 8. So with that, go back to equation 1. This is equation 2 from 1, so that is from a over r plus a plus a r equal 28. So if I replace this with 8, so we have a over r plus a r to be equal to 28 minus 8, and that is 20. Again, we said we have a to be 8, so we have that as 8 over r plus 8r equal 20. If I multiply it by r, so I have 8 plus 8r squared equal 20r. If I write this, that's ar squared negative 20r plus 8 equals 0. So I'm having a quadratic equation to solve. Again, I can divide through by 4, so I have 2r squared negative 5r plus 2 equals 0. What would that be? So we solve this by factorization method. That will be negative 2 negative 4r, if I'm not mistaken, negative r plus 2, yes, negative 4r negative 4, that's plus 4, so yes, equal 2. So if I have 2r, I have r negative 2, I have negative 1, so I have r negative 2 equals 0, which leaves me with 2r negative 1 into r negative 2 equals 0. So we have 2. Now, when you have 2, we have no multiplying is going to be equal to 0. In an integral domain, don't worry, it just means that either of them is 0. It can't be the case that none of them is 0. So that means either we have 2r minus 1 equal to 0 or r minus 2 equal to 0. So such that we have 2r equal to 1 or r equal to 2. So which is r equal to 1 over 2. Or we have r equal to 2. Now, so we have 2 common ratio here. So that means that we can have the case when common ratio equal to 1 over 2, or we have it when we have r equal to 2. You may actually want to check. Recall we said the term was a over r, said a and a carry. Now, if I'm using 1 over 2, so 8 divided 1 over 2, the first term will be 16. Second, that'll be 8, and next one will be 8 times 1 over 2. That is when r equal to 1 over 2. That's what I'm using. So I will have 8 times 1 over 2. That's 4. Now, if you had all this, 16 plus 8, that's 24 plus 4. That's 28, which gives the sum. Just as it was said, the sum is 28. What of it when you multiply? What's 16 times 8? 8 times 10, 80. 8 times 6, 48. That's 128 times 4. That's 128 times 4, 256, 512. Yes, that's the multiple. True. Also, let's check when r equal to 2. When r equal to 2, so we have 8. The first term, that will be 8 divided 2, that will be 4. The second term will be still 8. And the third term, that will be 8 times 2, that's 16. Now, if you had this, what do we have? You can see that's still 4, 8, 16. What we had initially is 16, 8, 4. So addition is actually commutative. So that is 4 plus 8 plus 16, something like 6 plus 8 plus 4, which gives the 28. And also when it's being multiplied, multiplication also is commutative. That is 4 times 8 times 16, 16 times 8 times 4 is still 512. So as such, we have our 8 to be equal to 8 and r to be equal to either 1 or 2 or r equal to 2. However, now the question was, what are the numbers? So the numbers are, the number could be 16, 8 and 4, or 4, 8 and 16. So depending on what we choose. Thank you. See you in our next class. Don't forget to share, subscribe,